Hello, everyone, and welcome to day 9. Okay, so let us quickly, as always, look at what our agenda for today is. Today, we will fix the continue bug we encountered yesterday. And then we will go ahead and look at what the term algorithmic thinking means. Maybe coming from the word algorithm itself, we will look at that one also. And then we will also introduce ourselves to the concepts of pseudocodes, whatever they are. And I think that would be all. Sorry, I did not intend for you to see that one. And so it's kind of a lot of things, but I've consolidated them into these three main parts. Okay. So let us get into Python and then start dealing with the first. I'm sorry about the bug yesterday. I actually wish I can say it was intentional. It was not intentional. And if you didn't like it, like you felt like why should it be so and all that, I'm sorry if I didn't meet your expectation yesterday. But that is to say that, to be very honest with you, such things happen. One, it's not easy to fix a bug when you are live, when you are like live like I am now, and especially when you know you have limited time, you tend to think, let me say, faster. So you might miss some very minute details which might give you those problems. And then number two, that is how it is in the real world. To be very honest with you, even the most seasoned of developers you know have to deal with bugs that can take not just hours, sometimes days to solve. So yes, yesterday's bug. That is why I've not touched the code. I just copied it over from day 8. So we use today's principles that we are coming to learn to fix the bug here and then look at how we can properly approach any programming project or task that will ever be thrown at us. And so this is yesterday's code. Let us try and fix it. As part of the fixing of the code, I would like to introduce us to a principle that is called, very popular principle in programming. It is called the rubber duck principle. Yes, let me show the banner. So you can see the banner beneath the stream is the rubber duck principle. And it's just to say that you get like a rubber duck or any inanimate object. So you have any inanimate object like a toy, you can use that for that purpose. And what the that rubber duck does is that it acts as your debugging companion. And so you tend to explain to the duck line by line what your code is doing. And before you realize it, well, you find where the error is. So it is a principle in programming. It's a simple but very effective technique that you can use to troubleshoot your code and find where the errors are. So how do we do it? You get your rubber duck or any inanimate object like your toy, and then or if you even if you can get somebody who will be interested in listening to you, you can also do so. That will even make it more effective because that person in turn can ask you questions when you say something, but the rubber duck cannot ask you a question. So you explain your code line by line to the rubber duck, and then you describe what each part of the code is supposed to do and how each part functions. So as you go line by line and explain your code to the rubber duck, you tell it, okay, line 6 is doing this, line 5 is doing that, and you make sure you give it in detail and how the code functions. So if I come to line 8, I should tell my rubber duck how this place functions. For instance, if I say I'm taking numbers, index numbers, what does it mean? How does this particular piece of code function? A minute, please. Okay. So if I get to this particular line, I have to tell Robert that how this particular piece here functions. So what does this thing mean? I have to tell it in detail so that uh, it doesn't actually hear you, but it's a principle that works. You can try it out. And so, as you explain, you might notice some discrepancies between what the code is expected to do and what it actually does. So, by verbalizing the problem or by speaking it out, you engage different parts of your brain and you also tend to gain some fresh perspectives. And so oftentimes from experience, I can tell you that explaining your code line by line, it leads to insights. And you might suddenly realize where the bug lies or how to even optimize your own code. And during my undergrad, I think the third year, we were told to write a software that will perform what we call datum transformation. I've really forgotten the particular thing, but it was supposed to transform coordinates, geographic coordinates, from one format to the other. And so what I did was I wrote the logical part, so to speak, of the code, the part that handles the logic of the conversion, and I tested it and it worked. And I wrote the user interface, the places where you can click and type, like this interface of PyCharm, where I don't have to take input from the command line because I should assume that I'm sending it to someone who will not have the privilege of the command line. And so the UI also worked. But the problem came when I was connecting the two sides. And in fact, I tried the connection and it never worked. So I left it and submitted the backend logic like that, assuming that the instructor would be pleased to run it and take instructions from the terminal. I abandoned it because I didn't know why it was not working. I went over the code over and over again until about weeks or many days. I found out that there was a place that I was supposed to. I swapped a comma and a dot. So whether it was a dot, I made it a comma, or a comma, I made it a dot, I can't really tell, but I swapped those two symbols, and that was all. The syntax was correct, but there was still an error in the code that did not make it run. So forgive me once again if you did not find it so much pleasing, but that thing also it happens. Yeah. And I should be honest enough to leave it so that you know that those things do happen and all that. So we will apply the rubber duck principle to solve this particular issue that we had. We were trying to do this thing. So now I will explain my code to you that are listening. So this is what I intend my code to do. Intend that my code does. I want to get a list of all numbers from 1 to 10. And then using a while loop, I want to now print all the numbers. But I want to skip when I get to number 5. So that means that if I get to the number 5, I shouldn't print 5 to the terminal. Okay, so now this is what my code does. I have my code first to declare the numbers here. So I'm explaining my code to you line by line. Today, you may not write new code, but I think still these principles are very vital for you in your programming journey. And for the part of the pseudocode, when we get there, I'll teach you how to write it, and I'll require it of all assignments that you do from henceforth. So henceforth, you'll be adding pseudocodes to your assignments. So at line 5, I got my list of numbers. And then this line 6 is the index, which I'm using to keep track of my while loop. Because the while loop I have to meet a particular condition to break out of it because I'm always setting it to true. So line 7 is where I initiated my loop. And then at line 8, I want to use this index that I have declared up here, pass it into the numbers list, and then so that in case when my index is 0, it will give me the first number, and then I will use it for some comparison here. So my comparison is that I should, that if I get to 5, if the number is 5, so in the case where it gets to 5 here, it should not print it. It should skip that line. So I don't want to see 5 at my terminal. That is what I want my line 8 and 9 to be doing. Other than that, I want to print the particular number. So if it is not equal to 5, then it should print it for me. And at line 12 is where I was trying to create the logic for the code to break out. Okay. I'm monitoring the comments as always. So if you have a question, you can put it there and I'll tackle it. Okay. Let me change the banner, because it is still the rubber duck principle, but we are still solving yesterday's bug. So let me put that one in. So correct, this part, I don't think I have to change anything. My index 2 will not be the problem. The while true itself will not be the problem. Okay, so now if numbers index equal to 5, continue. That statement looks syntactically correct, but let us run the code and see something. We find out that the code runs and it only prints 1. If I scroll up to the very top, it prints 1. That means that after the code ran through, the loop ran through for the first time, when it's tried to come back again and run, something happened. So it first passed this condition here, which is checking if it is equal to 5, and it was not. So it threw it to the else, and this else printed it. I can actually try debugging it by putting a print statement here that says, print else is now working. So I know that is the else statement that is now working. So if I run it again, I'll get this same infinite loop. But I am making progress now because I see that else is now working. So I know that the number 1 passed 8 and 9, which is the condition. So this part is doing what we are expecting it to do. And it came here, else was now working. That one was just for demonstration, so I'll take it off for now. And this one also will not be the problem, because if that's where the problem, it will actually break or something like that, because this number index here that we are checking, and the length of numbers, or maybe 13 is the problem. Okay, we can put another statement here to check. The print statement is also used for debugging in itself. So in this case, when I wanted to know whether the else was working, I typed else is now working, and I found out that indeed else is working. So let us examine line 13 and see if 13 is the problem, because I know that it skipped this one because the condition was false. And we know that, I know it skipped it. If you're asking me how I know it skipped it, I know it skipped it because this only one of these will run. One of these, either the if or the else. So if the if didn't run, then it means the else was running. And that means that this particular part of our code, which is the if block, rendered to false. So I know that the problem at this time is not coming from these two. So let us look at what might be wrong with our break part. Now we want to only break out if the index equal to the length of the numbers. So I think it is very wrong for me to put here that if numbers index. What this one I think will do is that it will not rather use the index for the checking, but it will use the particular number. So in the case where it gets to, say, 10, it will pass numbers 10 here. So this place will be numbers and then it will pass 10 inside like this. When it gets to the end, and I don't think this is something that we really want to do. This is not what I wanted to mean at that particular line. So I have actually detected one bug here that this place is part of the problem if it is not the only problem. So instead of saying numbers index, I only want to check if the index here, this number, if it equals to this part, which is the last number, or the length of the list, which is 10, then it should break out. It shouldn't pass the index in rather like this. I just have to check just the index to be equal to the length of the list. I don't know whether my explanation is really making sense, but I think it should. So this place, I think it should be this way rather. And then let's run it and see. Okay, so even though that did not really show us or did not fix the error for us, so we can put another print statement here and say end of loop reached. Okay, I'm intentionally taking time to do this so that at least you see how I fix my code if I have a problem, or some of the ways to look at your code if it is not working. I received some comments that some of you are finding it difficult. The second question of the assignment is becoming a little bit difficult. So it is all part to help us see how we can debug our code or even come up with the step-by-step process of solving the code problem, which is the algorithmic thinking that we will get to very soon. So at this end of loop, we know it will only print if index is equal to length of numbers. But here is the case, our code is only printing 1. It doesn't increase. So we have not gotten to 10. So we don't expect to even see this part of our code. Okay, so what is it that we can do to make sure that the number increases? It looks to me also here that there's a big mistake because I'm not increasing the index anywhere. Okay, so let me try and increase it at the end of the else statement and say index. Let me make it plus equal to 1. So after you check if the number is 5, continue. Other than that, print it and afterwards increase the index because I think I have to put it here before this break condition because I will need it here. So I should be able to increase it so that I don't exceed the length of the list and get, if I try to access something that is not in the list at that particular index, you know that I'll get an error so that it will not be an overflow. So hopefully let us see if this one will also fix it for us. And it looks like we have made progress, which is good because now we have been able to print up to 4. And you know that my code is still running because if you look at my top right corner, let me try and zoom in there. My top right corner, you see that it is still running. If I put my cursor on it, it says stop. That means it is running. We cannot stop it unless it is running. So I will click on it to stop it because my code is now stuck in a particular loop that I don't know about. When it got to 4, it is now having a problem. So we know that the problem is coming now from the number 5. So when it got to 5 here, that is where the problem is occurring. And if we look at our code carefully, we will know that then most probably, I'm not saying that is where it is coming from, most probably the error will be coming from this side. Because this is the side, I was trying to zoom into that side, okay. This is the side where we are dealing with the number 5. So this is the only part in our code where we are dealing with the number 5. And so let us do something and see if it is just the number 5 that is causing the problem or it is something else. So I'll change this one to 8 and then run it again. So now if it prints up to 7 and stops, which it did, then I know that indeed the error is coming from this side because this side is what is causing the problem. any number we put here, that means when the code gets there, it tends to have a problem. In our case, it was 5. Okay. So how do we go about fixing it at this particular side? Well, if the number equal to 5, continue. And then it seems to freeze rather at the continue session, but the continue is not to make it freeze. That means that we are caught in an infinite loop at this particular side of our code. So how do we make sure that we break out of an infinite loop? Remember, we are using a while loop. And the way we break out of infinite loops, we have already broken out of one, where the case is that it was only printing 1 to the terminal. We solved that particular issue by increasing our counter variable by 1. That was only applicable to the else statement because it was the else that is printing the 1 for us. And when we said that, okay, after printing the number, that means after the else statement, now increase it by 1, it solved the issue. And then it now came to look at this particular place where it was supposed to check the condition for us for that special number. So that means that if we are also supposed to increase the index inside this particular block, sorry about that, let me do a rectangle. Inside this particular block, it will fix our code because it helped us fix the repeating one. So if there's any way we can add it here, that means that it can help fix our code. I'm not saying that it will, but it can. We are only trying to make inference from the old one that solved our recurring one problem. Okay. So I don't think we can put it after the continue. In fact, this one will be plus equal to 1. And already Python is yelling at me that, let me see what it's saying, that this particular code, I don't know whether you can see it on your screen, but it's saying that the code is unreachable. That means that after the continue statement, we cannot increase the index by 1. So let me now take it from here and then bring it before the continue statement. Now we don't have any error from Python. So that means that we can test it out and see, hoping that this time around, okay, it's already running. So let me stop it and then run it again. Okay. We now see our end of loop reached just before the breaking occurred. So let's now go through our code and see. And if you look at it, you see that our problem is now solved. We have one here, 2, 3, 4. But after 4, you see that there is no 5. And then 6, 7, 8, 9, and 10. Our code has done what we intended that it do for us. And yes, it escaped. So if we test it here with 7, we are not supposed to see 7 at our terminal. Okay, now the 5 is in, but the 7 didn't come. Okay, so that means that we have been able to solve our bug. So we have fixed our bug, that is the more technical term, or we have debugged our code. This place, I don't really need it. I don't think I need the end of loop also reached. So this is how we can think through our code when we get problems. Looking at some components of the code, at least in this case where it was giving us some outputs, we can base on the outputs and see where, if we know what should happen next after that particular output we have on the terminal, like in our case, it's printed 1. We know that after the 1, it was supposed to go to 2. So we knew that the problem was occurring after the printing of the 1, which was done by the else statement. And so we now tackled it from the else statement's perspective by adding 1 to it. And when we added 1, it fixed it until it got to the number that we placed here to skip. And so we found out that, okay, this one has now kind of become its own loop inside the loop. So we have to also try and increase the counter in here and see. And then when we did it, it avoided the infinite loop inside the loop itself also. I just hope that this has helped you understand what I'm trying to preach here this evening. That is to look at your code in different fragments, not trying to solve the whole problem at a go like I did yesterday. And I ended up in some bug that I couldn't fix and I have to fix today. Okay. If you don't understand any part of what I did, or if you have any question, you can put it in. Other than that, we will move to the next agenda for today, which is algorithmic thinking. Then we will close with them, pseudocodes. Okay, let me bring up the slide. If there are questions, I will answer. Other than that, I will proceed with this one. Okay, so what is algorithmic thinking? You can look at it as you kind of, okay, let me take it from the word algorithm itself. It's usually, let me give the most basic definition of what an algorithm is, especially if you hear a developer or a programmer saying it. It's just a keyword they try to use to confuse people. It means a step-by-step process or procedure, laid out procedure to solve a particular problem. But if they want to confuse people, a layman, they usually use the word algorithm. Algorithm. What is this algorithm? It sounds like a very big word, but no, that is not it. If I am looking at how to multiply or how to add two numbers, the algorithm can be as simple as take the variable, take two inputs from the user, declare a variable which is equal to result, which adds the two values from the user, and then print the result to the terminal. I've just spoken about 3 lines here. So that is my algorithm for adding two numbers. So it's just the step-by-step process. So if we expand that knowledge into what algorithmic thinking is, especially in relation to computer programming, I will say that involves approaching a problem in a systematic way, sorry. It is akin to how a computer processes information. So you look at the problem and you also look at how computers think and what particular syntax or instructions, how am I supposed to even, if I'm using Python, how can I type this in Python code? And so you begin to look at it in a systematic way from one to the other. So it's a mindset, so to speak, that enables you to break down complex problems into smaller manageable parts. And when you do that, it helps you to devise efficient solutions and very optimized ones, to be precise. So it doesn't really apply to programming alone. If you are solving any kind of problem, you can use algorithmic thinking to do that, where you break the complex problem down into smaller manageable parts. And then you try to solve the parts or the pieces, and then you put them together. Okay. No comments? Okay. So if you want to understand somebody's algorithm or you are writing your own, this will also still help you. So let us look at what we term as some key aspects of algorithmic thinking. The first one is first exploring the problem. So if you are presented with a problem, I will not try to limit this one to only coding. But if you are presented with any problem, your first step to efficiently solve it is to begin by understanding the problem itself. So, what is this problem all about? What is it all about? You understand the problem itself. So, once you understand it, you can go ahead and decompose the problem. That is the breaking down of the problem into smaller sub problems. So, if I present you with the book library example, the question 2 like this, don't immediately think about a book library in Python you just have to now understand, okay, so what is a book library? That means that at the end of the day, I should have whatever it is that is representing a library. In the case where that now they said we should use a dictionary. So that means I should have a dictionary that has books, book authors, author names, and then the book titles. So now that you see that, okay, so generally it will be like a digital library where people can come and search for books based on this and that. So have an idea now. It's about a library, a digital one. So now you begin to decompose that particular problem into smaller sub problems. Now, okay, fine. It is a book library. In this context of programming, how many parts or what are the sub parts or sub components I can decompose this particular huge problem, so to speak, into? So you maybe think, okay, fine. The question is asking us to implement a search. So I'll have a search part. Even inside the search part, I can break it down smaller. The user's inputs and my own algorithm to use the user's inputs to search through the dictionary, or in this case, the library, to have the search part. Okay, so it will have the database of the existing book itself. So that is also becomes a sub part or a sub component you are looking at. So if I'm looking at the database, how do I keep the database which the user will come and now query? So how should the database itself be? So now we have dealt with the search part, the dictionary. Apart from that, is it any other thing that the problem is telling me to tackle? Oh yes, it tells me to allow the user to add to the book dictionary. So what does that one even mean, and how do I implement that one? Can I handle it at a go, or I should break that part two into smaller components? And then now you begin to look at it and say, okay, fine. I can also now break that part into two, where I take the book that the user wants to add, and then I write my own algorithm to add it to the book. So if you begin to look at it in this smaller, even sub components, it doesn't become the huge problem or the huge impossible problem, so to speak. So that is one of the ways I want you to handle your codes nowadays. So after decomposition, we now go to what we will term as abstraction. And what do I mean by that? You have to now focus on essential details while ignoring irrelevant specifics. What is the code telling me to do? Fine. I may want to style up my code to impress the instructor or whoever gave me the problem. But there are some core things I have to handle first. So don't just focus on how you want it to be, like how you want to style it to impress or anything like that. Focus on the essential details you have been given and ignore irrelevant specifics at that time. Once you are able to achieve what the basic requirements are or what the requirements are, now you can go ahead and look at, okay, how do I improve upon, or even how do I optimize what I already have to make it better or to make it more user friendly or anything else like that. So after that, you also go to the algorithm design. After that, you have explored the problem, decomposed it. So you now understand the problem, you have broken it into subcomponents, you have detailed out or circled out the most important ones that you have to tackle. You can call them the core ones or the pillars on which the whole problem stands. So those ones, if you get them done, you have virtually solved the whole problem. Now you can tackle the minor ones with ease. Then the step that follows in the algorithmic thinking process is the algorithm design itself. So that is where you create a step-by-step instruction for solving the problem. So now I take each of my sub components, and then I now begin to write the code to solve those problems. Maybe I may not have one on this current. I changed my disk not long ago. Other than that, I would have shown you some of the ways I write my files or my projects. Usually, you will not see me putting everything in one file. You may see me breaking things down, trying to now bring those small pieces together. So I write smaller portions of the code or the problem. So I write it in smaller bits. I tackle it, sub components, sub components, and then I try to piece them now together. Even in the piecing together, I do it step by step, very carefully. So I know that this is what follows this, and this is what follows this. So at every point I get an error, I know where I'm supposed to stop and fix it. I don't copy and bring everything together at once. After I abstract, I design the algorithms for each of the subcomponents. Now I begin to piece them together. So after this algorithm design and implementation, sorry, I should have brought the implementation of the algorithm also. So you can take it that way. Let me see if I can edit it. So algorithm design and implementation should be the correct word. And implementation. Okay, so the algorithm design and implementation. Sorry about that implementation. Okay, I have it now. So we design and implement the algorithm, and after you are done, you test it. So you validate your solution through testing, and then you refine it. So now that you have finished the book library, you begin to test this based on the requirements that you are given. So the things that you now got at the decomposition and abstraction phase, all the things that you now got at the decomposition and abstraction phase, use those ones to test it. So here you broke your code down into smaller pieces, into smaller components. Now that you finish, you use these small components, and even with this abstraction phase, you use that one also to circle out the most important ones that you are supposed to tackle first. So maybe let's just suppose that it is this sub component and this sub one. So you are now done with it. You have designed and implemented the algorithm. Now you begin to test it. First, probably I recommend with these most important ones that you circled out. So use these ones to test. Sorry, not iteration. I mean the test. Use these ones to test, and then let me just cross. Forgive me. Use that one for the testing. And then after you test, iterate and test multiple times, you can now use these ones to implement your iteration. So these ones too can become like a backup testing plan uh, for you, just so that you'll be safe. Because in most cases, if it is a website, a software that you are building, an algorithm, anything you are doing for somebody, after you send it, that is it. Yes, you might be able to fix bugs and then resubmit, but most of those minor bugs that come, especially immediately after the user implements your algorithm and find out that there's a problem. If you really tested your code, like if you took this last part serious, those errors should not occur. So this is as important as all of them that has come before. I think I have one comment. This is as important as all of those ones which has come before. Okay, so make sure you test it. I don't know what I've mentioned this year in any part of our boot camp, but my team and I wrote a software last year, and during the testing phase, there was a particular error we never saw. We tested it, we ran it on multiple PCs. There was even a beta version of the app where we released that version for users to test it and give us their feedback. Feedbacks were given, we worked on it, fixed the bugs that were brought through the feedback. And then we ourselves looking at things, we found out, okay, fine, we can consolidate this idea into this and all that. So when I was touring the classrooms and displaying the software, I came across an error that I had never seen throughout the development and testing process. But because also the algorithm was designed in such a way that it will capture unforeseen circumstances. So we'll get to that part where we design our code to catch every possible occurrence, at least as far as we can do. Sorry, as much as we can do in terms of usability, all that. So this is the algorithmic thinking. I just hope that you've understood it well. As I said, don't only apply it when you are solving programming problems. You can apply this to all life problems, and you see massive results and outputs that you'll be able to bring out. Okay, if there is any question on algorithmic thinking too, I would like to address. Other than that, we will move on to our last option for the day. So 1 minute, and then we can continue. Okay, so there is no question. And so we can look at what we call pseudocodes. Okay. I'll bring up the banner. So that is it, pseudocode. It is also a code, but the pseudo means false. So in this case, we can say that it is not the actual code you are writing, but it's in itself. Maybe I should type it out. That will make more sense. In itself, it's code or something that will guide you, but it's not the actual code itself. So you can look at it as a description of a description of an algorithm that uses human readable and understandable language. So it is kind of similar to programming language, so to speak, but without the strict syntax rules. So that one will serve as an intermediate step between a problem statement and the actual implementation of the problem or the solution, in this case, in a specific programming language. So what is all this that I'm saying? Probably you don't get me that much. So let me go ahead. This particular code that we have, and let's see how we write a pseudocode for this particular problem. Okay. And so for that, I will create a brand new file inside the 9. But that one will be an ordinary file. I'm not creating a Python file to be an ordinary file. Yeah, this one that I'm choosing. Okay, the first one. And then I'll give it a name of maybe pseudo.txt. This one I have to intentionally specify that it will be a txt file. So if you are following along with me, make sure that you add the name also there, the extension also there, .txt, which is just the extension for a text file. I know it may be very hard for you to see if I put the two editors side by side, but that's what I'll try and do so that at least we'll appreciate whatever is going on at both sides. So in PyCharm or even in VS Code, it's also possible. If you click on the name of the file, like what you see this here, we call it a tab. A tab. So TAB is a tab. If you click on the tab and then drag it, you see that it has now been taken away from the top there. But as I come closer to the end like this, if I release it, it will put the screens, the two editors or editor windows or the tabs, so to speak technically, side by side. So I now see my code at the left and then my pseudocode.txt at the right. Okay. That is great. So now let's see how we will write pseudocode for this. So as I said, it is a code or a guide in itself, but without the strict rules of a programming language. And there's no particular way to write this. You cannot be right or wrong, but you can be wrong, but we don't really have, like, in quotes, a strict standard to follow. So all will have to come from intuition, and I will require it of you nowadays in all the assignments, because I want to understand how you do, or you wrote the code, and how you went ahead implementing your algorithm with the algorithmic thinking process that I just explained a few minutes ago. So let's see how the pseudocode for something like what we have here will look like. So what am I doing at line 5? Usually you write your pseudocode before you write the code itself. But in this case, is the code that is coming before the pseudocode, because we have to fix this back here. So usually you write your pseudocode before you do this. And so for line 5, so what I want to do now is to print all numbers. So I can here say that the task for this is to, print all numbers from, not from 1 to 10. I'll try and be spacing them in the next line so that you see what I'm doing. But skip maybe actually that is the printing if the number, I said I'll bring it to the next line. If the number is 5. I just hope you understand my sentence here. And so that is the task. So now let me see how I don't expect you to put the task in the pseudocode, because I already have the question. But in this case, I just want you to understand. That is why I'm adding the task. So now I can say, okay, fine. How do I now start? I need a list of numbers from 1 to 10 because I'll be using it. So I can say, okay, initialize. If supposing that is the first thing that I want to do, initialize. I want to use a list. I've decided. So initialize a list of numbers from 1 to 10. And then I can say that my next step, let me just try and beautify this thing here by this hyphen, just to make it look like I'm going step by step. So the next step is to, okay, I'm using a while loop, or which loop am I using? So in this case, the question says I should use a while loop. So maybe I can say declare a while loop to iterate over the list. So I know that in another point in my code, I'll be doing this particular thing. And then maybe the next step, I'll say, okay, while I'm doing the iteration, what will happen? Usually, let me close this one here for now, or let me bring this one here to show you something. So this one will also come here, because I want to show you something. Now, this part, declare a while loop to iterate over the list. It is not strictly required, but I know that loops, whatever falls inside the loop is indented. So I can also indent in here like this. It's not strictly required, but it makes your pseudocode readable. And anybody who picks it know that you are a good programmer. So I can say, okay, inside my loop now, because I've stated here that I have declared a loop, or I will declare a loop in this case. Inside the loop, what do I want to do? Okay, so I can check if the number is 5. And so, you know here also that I am checking if. That means that this place is also a condition in itself. So if I check if the number is 5, I can also come down and now indent again and say that, okay, if it is 5, skip it, skip, or maybe skip it, skip it, do not print it. Continue to the next number. Okay, so this is what I want to do if the number is 5. Okay, but what if it is not? That means that I have to now come out of the if condition. So I'll come to where the C starts, just this indent here, and that is where I'll declare my other condition. So if it is not 5, print the number. Okay, so, but I'm using a while loop. That means I have to get a way of increasing the index because I'm told to do 1 to 10. And that is a list. So I have to now check if I've gotten to the end of the list. So that means I forgot to actually declare a variable that will keep track of my position. So let me say I'll bring that one in here, say maybe initialize variable, maybe a variable to keep track of the index, or the list index to be precise. So the list index. So initialize a variable to keep track of that. Maybe we can call it index so that anywhere in our pseudocode we can just type index to refer to this particular line. So here I know that after I've checked this, I have to now increase the index. So increase the value of index. So you see that I have not given another hyphen. So we are still in the while loop. And that is because everything here is happening inside the loop. The rest of our code has to be in the loop because that is exactly what our program requires us to do. Keep on printing. So we have to still be in the loop. So now that we increase the index, how do we, the only thing that we have not done so far looks like we have to now increase or declare the condition to stop the loop. So how do we do that? That's when we can say, okay, if the index is equal to the length, I get it from length of the list, then this is also a condition, so we can indent into it and say exit the loop. And so this one now becomes what we call our pseudocode. If I give you something like this, it doesn't look like a Python code, but at least it gives you an idea of what the implementation of such a thing will be. So if I give you just something like this and tell you to, okay, developer, I want to implement this particular logic in Python. It will be easy for you to just follow what I've done here and type the code with ease. With ease, you finish typing the code because when you read through, you understand that this is what you have to do. Even though I've indented it to make it nice and pretty, but that doesn't, it's not a strict requirement, though I'll require it of you. Yeah, but I think this place too could have come in as an indent here, but on one line, I don't think it's still a problem. So this now becomes the pseudocode for this. Is the false code for this. not in any programming language. It's not a programming language. It's not in any, when we run this through any programming language, it will throw an error. But it gives us an idea of how this particular one will be solved. Okay. That is the whole concept of pseudocode, this step-by-step guide, which looks like we are writing the code, or it looks like how we will think while writing the code, but not the actual code itself. Yes, that is the idea of pseudocode. And then from henceforth, all your assignments, you have to now present pseudocodes also, so that I know how you thought through the whole process to the end. And so that will also bring us to the end of today's session. If there are no questions or confusions I have to address, then we can bring the session to a close and anticipate for the next day. Where do you click to write the pseudocode? Okay, I came into my day 9 folder here. And then I wanted to create a new file. That will not be a Python file. I will require you to produce your pseudocodes in .txt file. So I just right click, choose new. And this time around, I'll not choose Python file. I'll choose file. Just the first one, the first option. And then when the new file dialog opens, this one, what I did was to type, you give it any name. In this case, I said pseudo.txt. But in this case, we have to intentionally put the .txt at the end. Other than that, it will still work, but I will not recommend that way. So pseudo, and then just put .txt, or you can name it anything here, my pseudo code, or anything like the name of the file itself. Also, maybe the nice pseudo, but don't forget the .txt at the end. So once, if I create this one as pseudo 1 and I press enter, you see that another tab opens at the top there for me, apart from my 2 tabs which are already opened. I'm trying to bring all of them. So I have my day 9 file here, my pseudo, the one that I've written in, and the pseudo one that I just created. So I'll close out of that one. I don't need it. But most importantly, if you come to the day 9 folder, you see it over there also. So I don't need it here also. So I'll just click on it and then hit delete. Okay, so I believe I've tackled that one. It's just a new file that I created. Please, any more questions? Okay, I don't think so. So we will end today's stream also. Today we did not learn to write any new code. Tomorrow we will do that. But I just wanted to make sure you get this right and then apply it to all the problems that you hereafter solve. After the stream, I will still be in the studio for a while. So if I still have to answer your question in the stream, I'll do that, or in the studio, I'll do that. Other than that, you can put it on the WhatsApp platform also, or message me directly, whichever one is convenient with you. So thank you for your time today too. Until tomorrow, when we meet again, make sure you keep practicing. I want to see you do things that are outside what you've done in class. I'll be glad if you show me such works. So until then, keep coding and goodbye.